There we go. Now we'll resume recording. All right, so we are into week 6. It's so crazy. And week 6 brings us to our second week of chapter 5. So chapter 5 is a big, intense chapter all about hormones. So the reason that it is such a comprehensive, huge chapter is because there's several different ways that hormones can be categorized. And that becomes important from a management perspective if we're talking about how the hormone is biochemically activated, how it's classified, or the way that it actually elicits its response. And so that's, you guys spent last week working through the first part of that and just kind of getting an overview of the major hormones that are a part of the reproductive system in our livestock species. And then you worked through the endocrinology quiz last week as well. And so this week with the chapter 5B material in week 6. So that gets a little confusing because it's our first deviation away from the nicely correlated week 1 is with chapter 1 type of scenario. But this week we are looking at the second week of endocrinology. And so you guys will be getting into the mechanisms of action for steroids as well as protein hormones. And so that stuff is just cool. It's just awesome stuff. And so there's also this a folder for additional resources. So there's some really good videos in here on how hormones work, the difference between a steroid versus a protein. If you need a refresher on the review of the estrous cycle from a hormone perspective, there's a really good a link in here to a resource as well. And then if you're interested, at the end of chapter 5, they start talking about how we actually test to see if hormones are high in the system or not. And we can do that through ELISA, which is an enzyme-linked immunosorbent assay. And this is something that is done very intricately in like a laboratory setting, but it's also something that we've perfected and made readily available. So like pregnancy tests are essentially ELISAs now, which is kind of cool. So, all right, so that is where we're at with material this week. So again, quiz for week 6 is due by the end of day on Friday, October 1st. It's hard to believe that we're into October, but all right. So that's where I wanted to spend some time, is just letting everybody kind of catch up to where we're at. And so I'm happy to take this session any which way you guys want. So it's really nice with only a few students to be able to give you guys that liberty so that we're talking about stuff that helps you. And so with that, I am up for questions or comments or directions, or if you guys are feeling pretty good about stuff and want to jump off, that's totally fine too. This is absolutely an optional session for you. So how can I help?
I have a super bizarre question. It's completely
Cool.
unrelated to what we've learned this week, so I can wait if other people have actual real questions. So yeah, I'll wait a little bit until other people have said theirs.
Okay, sounds good. So Marlon or Peyton, do you guys have some questions or some points of clarification?
I was more or less a little like lost in the study guide.
Okay.
And I don't know if that's just because I haven't done this week's lectures. So does the study guide encompass, oh yeah, it says week 5 and 6. I just opened it up again.
Okay,
And
yeah.
I worked on like what I could, but I wanted to make sure I had the entirety of it. But I guess I can just email you or something after this week.
Okay. Yeah. So if you are running into, I'm pulling it up right now, like questions about, oh, let's see here. The application questions like question 12 and 13, identifying key hormones, and, you know, if you wanted to short cycle a cow or something like that, and even 14, 15, those are all going to be answered this week when you get through the material.
Yeah.
So that's all about protein action and how they elicit their response. So yeah, so that's probably why you were confused and we're like, I don't know. It's because we haven't been through it yet.
Yeah.
Awesome. Peyton, did you have any questions?
No, not really. I think what happened last week was just like memorizing like where everything comes from. I just got kind of like there's just a lot to like process, and I think I kind of got stuck on that a little bit. But other
Okay,
than that, it's just I need to sit down and look at it again. But
cool. I mean, if you guys want, let me pull this up. I have some poll everywhere questions like ready to go.
Yes, I would love those.
Of what? What?
I said, yes, I would love those.
Okay, okay. Well, let me pull them up and get them unlocked. And this is kind of like rapid fire stuff, so it might help cement some stuff in for next week. Yeah. Okay. Okay, so I have to unlock them to clear the responses. Okay, so let me throw the link to pull everywhere in the chat. And we'll run through some rapid fire hormone secretion questions, okay? Awesome, okay, and then I will go ahead and share my screen with you. Actually, I'm not going to because I'm pretty sure I have to go in and edit them individually, so. All right, so if we get into present mode. Okay, so first question, guys, it should be activated and unlocked and everything. If you have issues, just holler out. So GnRH is produced in which tissue? Anterior pituitary gland, hypothalamus, ovary, placenta, posterior pituitary gland, the testes, or the uterus? All right, I'm gonna give you guys like 15 more seconds.
Is it made in the cell body of something?
Yes. Yes, it is.
I should know this.
Okay, here,
Yeah.
let's see. Did you already enter your response on Poll Everywhere, Caleb?
Oh, whoops. No, not yet.
Okay, you're the one I'm waiting on.
Oh, what the heck? Let me, I think I can do it on my phone, can't I?
Yeah, you should be able to.
What is your key thing again? Your like thing I have to accept.
Ooh, I don't know.
That's right. I'll just click on the link you posted.
Okay.
You guys can go on and I can do it on the next one.
Okay. I gotta get back to where my stuff is at. Oh, I think the key you were looking for text was 37607.
Okay.
There we go. Okay, so let's see what the responses were here. So hypothalamus, and you are correct. All right, guys. So hypothalamus is absolutely where gonadotropin releasing hormone is produced. So, and Caleb was right. It is produced in the cell body of the neurons, the GnRH neurons. So, we call GnRH a neuropeptide because it is made up of amino acid sequences. There's only 10 of them though. And so it's a really itty bitty small protein or a peptide. So neuro means in the brain and peptide means a small protein. All right, cool. Good job. All right, so let's go to our next one. Unlock it, I've got to activate it, and I've got to do that. Okay, so let me clear the responses. There we go. Okay, so progesterone or P4 is produced in which tissue? All right. Okay, guys, good job. So responses are, we have a response for a couple of different tissues. Okay, so progesterone. So first of all, and you guys can talk to me for this question, what classic or biological classification is progesterone? What type of hormone is it?
It's for reproduction, right? Is that what you're getting at?
It is for reproduction, not quite what I'm getting at. Like,
Okay.
what category does it fit into? Is it a protein, a glycoprotein, a fatty acid, or a steroid?
Oh, steroid.
Steroid, yeah. Why is it a steroid?
Because it ends, well, I remember because it ends in "on."
And it ends in "own." Exactly. Okay, cool. So anything that ends in "own" or "ol," right, is going to be a steroid. So like estradiol. Okay. And so with progesterone, because it's a steroid, it's actually going to end up being produced by the ovary. Okay, so the progesterone is going to be produced by the ovary, but more specifically, it's going to be produced by the corpus luteum on the ovary. And so what are some fun facts about progesterone that you guys learned last week? Caleb already said it's a hormone of reproduction, which is great. What else?
I forgot how general that is when we're in a repro class.
Not a problem. So if we had to narrow that down, it's commonly called the hormone of what?
Ovulation.
Not ovulation, good guess.
Isn't it the pregnancy?
Pregnancy, the hormone of pregnancy, yeah. So if progesterone is the hormone of pregnancy, what does that mean from a production standpoint? Like, when is it going to be produced in its highest concentration?
Right before, like when they're in heat.
Okay, so good guess, Marlon. They're actually, when a female is in heat or receptive to a male, progesterone is going to be super, super low. Okay.
That does make sense. This makes sense. Okay, so after they've conceived, or
Yes, after they conceive, yes.
okay.
So progesterone is going to be high anytime there's a corpus luteum as the dominant structure on the ovary.
Yes, I remember.
Okay, cool. So remember, corpus luteums are going to develop in the spot where ovulation occurred. And so if pregnancy is successful, like if conception is, or if fertilization took place, if the pregnancy, the embryo was attached to the uterus and is growing and gestating, and if pregnancy is successful, then the ovary is going to hang on to that CL the entire pregnancy, and it's going to continue to produce progesterone. So what are some other cool things that you guys learned about progesterone last week? Do you know some of its target tissues? We know where it's produced from, but what other tissues does it target?
According to my notes, it's in the placenta. Wait, placenta. Is that right? Did I put that wrong?
It'll be produced in the placenta. Yep.
Oh. Although that doesn't change anything. I was just rattling that off.
Nope, that's good. I appreciate rattles. Rattles are good. What else does progesterone do? Where does it go? So if we know that it is produced from the CL on the ovary, and we know it's the hormone of pregnancy, what is the target tissue going to be during pregnancy?
Can you define target tissue? Is that meaning like what is it trying to affect? What tissue is trying to affect?
Yep. What tissue is it traveling to elicit some sort of response? So we know where it's produced, right?
Right.
CL on the ovary. Where does it go?
The uterus.
Uterus. Yes. Great. What does it do at the, or to the uterus?
Does it help with lining?
It helps with not necessarily building a lining. Okay, so in our livestock species, they don't have like an endometrial lining like humans do, like we do. But what progesterone will do is it's going to go to the uterus, it's going to target its receptor there, and it's going to calm everything down. So the contractions stop, the smooth muscle contractions stop, because we need that uterus to be calm so that what can be established?
The fetus.
The fetus, exactly. So it can attach to the uterine wall. And so if the uterus is like contracting, and think of like, you know, something in labor, right? So the muscles of the uterus are contracting, trying to push that baby out. Similarly, when the female is in heat and estradiol is really high, we also see contractions of the uterus to help move sperm through the uterus to the oviduct. Okay. But once conception has taken place and fertilization has taken place, then we need progesterone to be really high and feed back to the uterus to calm everything down so that new embryo can start to attach. All right,
so cool. Before it's given birth, correct?
Correct. Yeah. This is way clear back at conception.
Oh, wow.
Yeah. Yep.
So will progesterone stay high throughout the whole pregnancy too?
It will. Yeah. Really high.
And
There's
then
still, it's kind of cool. It's one of those things like that dominant CL is going to stay as the main structure on the ovary, but at the same time, the ovary is also going to be going through follicular cycles, but the estradiol that's produced from the ovary can't override the high levels of progesterone.
Okay.
Yeah, it's kind of one of those cool conundrum things.
And then in my notes, I saw something it said about how like increasing or decreasing progesterone affects the GnRH.
Yep.
I was a little bit confused about that a little bit, like what that is.
Yeah, so we're going to expand more on that when we get to chapters 6, 7, and 8. But what ends up happening is progesterone is going to be produced from the CL on the ovary, and it goes to a bunch of different tissues, right? So we know that it goes to the uterus. It's also going to go to the vagina. It's going to go up to the hypothalamus, okay? And what it does at the hypothalamus is it elicits this response, or it triggers this response that we call negative feedback. And what that means is that it downregulates or stops GnRH from being produced at a really high level. So if we have a drop in GnRH, we're going to have a drop in LH and FSH. And that means that we're going to have a drop in ovarian activity, which is totally fine, because we want that CL to be the dominant structure on the ovary so that the pregnancy or the uterus is calm and that pregnancy can get established.
And then the opposite of this whole process is standing heat, because then
Correct. Yes, absolutely correct. Yep. So Marlon, take us through standing heat. What structure do you think is going to be dominant on the ovary at that point?
well, I know it's not CL.
Okay, great. Elimination. Awesome. So if it's not a CL, what is it? There's only one other choice.
mm, Oh, I was thinking of LH, but I don't really know. I'm just throwing things out there.
Okay, so LH is the hormone that comes from the anterior pituitary gland. So good guess, but no. So what structure is going to be on the ovary when a female is in standing heat? If it's not a CL, it's starts with an F.
Follicle.
Follicle. Yes. Okay. So those are our two major structures, right? So we either have CLs or corpus luteums or follicles, right? We can also, and this might be the point that you guys were thinking of, we can also have a corpus hemorrhagicum for a little bit of time, a really small CL. You can think of that as like a baby CL, or a corpus albicans, which is after the CL has disintegrated. Okay. And so, but CL is the one that we're going to talk the most about. It's the most important. Okay. So it's either a CL or a follicle. So that's great. If that means the follicle is going to be the dominant structure on the ovary. Great, great, great. Okay. And then what hormone is that dominant follicle going to produce at really high levels during standing heat?
Estradiol.
Sorry?
Estradiol.
Estradiol. Yeah, exactly. So when estradiol is high, the uterus is like angry and contracting because it's trying to help push sperm through to the oviduct, right? And then when progesterone is high, the uterus is calm so that attachment can take place.
Mhm.
Cool. You guys feeling better about this stuff?
Yeah, definitely.
Awesome.
Okay, so this kind of leads to my weird question I was going to ask earlier.
Fantastic.
I don't know how any of this works out, but to be completely honest, so me and my future fiance have been talking about birth control a lot, and
Mhm.
I have like all these varying opinions on it because I work in the workforce, and so, or I as a laborer, so I hear all these guys like, don't ever go on it, it's horrible for her, it'll hurt her, it's going to ruin her genetics. And then I talk to other people like my parents and like, dude, it's obviously it's always her decision, but hey, it's something that's really helpful. It makes everything well. So I want to know, do you know exactly what happens inside her if she were to do something like that, like with the corpus luteum or the follicle or however that works to make sure that pregnancy doesn't happen, and whether that's something that would impact negatively or not? I know it's not
Yes.
animals, but I know you'd have some sort of an answer.
Yeah, and we actually talk about this in class. So when we get to chapter
No
7,
way.
we're going to talk about birth control. Yeah.
I didn't know that.
So birth control, the pill, is a combination of progesterone and low levels of estradiol. And so
Both.
so it's
No way.
exogenous hormones, right? So it's kind of along the same lines, not exactly the same, but it's kind of along the
Okay.
same lines of us implanting cattle with hormones to help them grow faster. Okay,
Okay.
so these hormones already naturally exist in her system. We're just giving her more of them. And so with the increase in progesterone, what that does is make sure that that CL stays on her ovary so that she's not cycling and ovulating.
No way.
Yeah.
So that's all it is. It's basically, they're basically going to up the ante of progesterone so that it says, corpus luteum is staying dominant right now so that there can't be any sort of formation or ovulation.
Right. So, and that's why you have to adhere to a really set, stringent calendar, right? Like you have to take the pill every day. If you miss a day and you mess up your hormones, chances are like a follicle could develop and be the dominant follicle. Yeah. So we're going to talk about it more in depth. There's a little bit more to it than that, but in the context of estradiol and progesterone, that's what's going on.
Are there a lot of possible issues, or not a lot, like are there common issues that can happen from being like, okay, there's way too much, the corpus luteum's way jacked up now, or?
Yeah, so this is my opinion, this is not coming from science. I would have to go back and look at the science, but we know that there is correlation between birth control and early stroke in some women. We know that there is correlation between increasing levels of estradiol no, that's not right. A decrease in estradiol during menopause and breast cancer. There is some stuff out there. And so this is definitely a conversation for her and her physician.
Yeah.
And she may even want to, have some conversations with other women in her family that she has common genetics with.
Yeah, right? She has been.
Good. Yeah.
So.
Yep. Huh. Don't go into it blind. Everybody, definitely, I think in light of all the vaccine stuff, I think it's probably good that this is coming up because with the vaccine talks, like we've become really, really conscious of what we put into our bodies, right?
Yeah.
And this is not unlike that. So it's not a vaccine, but it is something that we're putting into our bodies. And I know as women, like it becomes pretty common, as you're growing up in junior high and high school, like everybody starts talking about birth control and sex ed classes and your peers are on birth control and all of that stuff. So you think it's absolutely a solution for you. And at the end of the day, it's still your health. You need to take responsibility for that.
Yeah. How does it affect you overall? Are you going to be impacted negatively, even though you're sacrificing something else?
Yep. So
thank you. I appreciate you talking about that.
Oh yeah, no problem. I love doing this like in-person class because it gets super awkward and I love that. I think that's
awesome. Well, I needed to talk to someone knows what they're talking about. So
are we recording? I should stop recording.
Control is kind of like a calendar, you can say. I really compare everything I learned in animal science with real like humans, but could that be managed? And now I see why it's like not as effective as a lot of people think because of those misconceptions of how long it really is.
Yeah.
No, I guess it was just kind of like food for thought, not really a question.
Yeah, no, I'm all about food for thought. So it's interesting. It's, you know, we think we know about stuff, but what we're told in doctors' offices is probably not everything that we need to know, right? And that's not their fault. Like, it's their job to inform you about the hormones and the drugs and stuff like that. But we rely on schools to teach sex education and the cycles. And we all know that that doesn't happen really, really well. And then let's add in, you know, like, as students, you guys sleep in between needing this information from your brain, right? So we forget stuff too. So I like talking about this because I talk about reproduction. I teach this class every semester. So, and this is what I do. So I, you know, all that stuff is kind of up here in this part of the brain. So, but for students, it's harder because you guys are trying to learn other stuff too. So that's why, you know, making sure that we're really in tune with our body, like how we're feeling, what we're taking, what we're putting into our body, all of that good stuff is really just something to be aware of. So cool. Okay, you guys want to roll back to some other questions real quick?
Yeah, sorry about that.
No, I love it. I think it's great. Okay, so let's see here. Let's go to the next one. I'm gonna unlock it, clear responses, and activate. Okay, there we go. So estradiol, or estrogen, also called estradiol or abbreviated as E2, is produced in which tissue? So is produced in which tissue? All right, let's go 15 more seconds, guys. All righty. Okay, so our responses is the ovary. I'm so glad we just had this discussion. Everybody got it right. Good job, guys. Good job. So the placenta is also where estradiol will be produced, but we just haven't talked about it in too much in depth. So I'm okay if you guys didn't get that one. All right, let's go to the next one. Unlock, do instructions, clear responses, and activate. Okay, so ECG, or equine chorion gonadotropin, is produced in which tissue? All right, here we go, guys. So responses, so placenta and posterior pituitary, and ECG is actually just produced in the placenta. So ECG is going to be one of those hormones that we can do a blood test for to see if mares are pregnant. Awesome. Okay, let's go to the next one and we'll unlock it. And let me clear the responses. Okay, there we go. All right, follicle stimulating hormone, or FSH, is produced in which tissue? All right, guys, let's see what we got. Okay. All right, so here, follicle stimulating hormone is going to be produced by the anterior pituitary gland. And so what FSH is produced in response to is actually GnRH coming from the hypothalamus. So when GnRH is produced in the hypothalamus, it's going to travel to the anterior pituitary gland, and it's going to increase production and regulation of FSH and LH. Okay, so follicle stimulating hormone was actually named for what it does in the female. We also see FSH be produced in the male, but males don't have follicles, but it has a similar type of response just in the male gonad.
So you said GnRH after it travels where? You said GnRH travels somewhere and then something happens
Yep.
with FSH.
So GnRH is produced in the hypothalamus.
Right.
Then it travels a very short distance to the anterior pituitary gland.
Okay. And that's when FSH is produced?
Exactly.
Oh.
Awesome. All
Anterior,
right.
right?
I'm sorry?
Anterior?
Yes, anterior.
Oh yeah, we just wrote it down.
Cool. All right. Next question. Prostaglandin F2 alpha, also known as PGF2 alpha, is produced in which tissue? All right, so just about 15 more seconds here. All right, here we go. All right, so we're a little bit all over the board. Okay, so PGF2 alpha is actually produced from the uterus. So when prostaglandin, or PGF2 alpha, is produced, it is done so in response to there not being a pregnancy in the uterus. Okay, so if there's no pregnancy detected in the uterus, and we'll go through the hormones associated with that in a later chapter, it basically signals prostaglandin to be produced. So it's produced in the uterus, and it travels to the ovary to kill the CL that's on the ovary. And this happens about 15 days after ovulation in cattle and horses, but it also happens at like day 13-ish, 12 or 13 in sheep.
When when it is produced, what is the purpose of it? So it notices that there's no pregnancy in the uterus, and then it's produced. I'm assuming that's because GnRH, or is that only because there's no?
Nope. So it's produced because there's no pregnancy, and
Okay, so
it
then what?
travels to the CL on the ovary and kills it.
Oh, no way.
Yeah. We call that lysing. So it basically bursts the cells and kills the cells of the CL. So the whole idea is to get it to regress so that the follicle on the ovary can become the dominant structure. And we can go through like the estrus cycle again so that we could try to get her pregnant.
You said it's called lysing?
Yeah.
How do you spell that?
Lysing. Lyse to
Lysing.
lyse.
Huh.
Yeah. Cool. Great questions. All right. I think I got a couple more here. So we'll unlock instructions, clear responses. Testosterone is produced in which tissue?
I hope I get this one right,
I hope so too.
especially since I'm a dude.
You said it, not me.
I don't see it on my screen.
Oh, it's probably, shoot, I forgot to activate it. I'm sorry, guys. There you go. Okay. Testosterone is produced in which tissue? Great. Okay, let's look. Okay, testes. Excellent, excellent, excellent. So we also see testosterone be produced to a small extent in the ovary and a little bit in the uterus as well. All right, next question. Luteinizing hormone, or LH, is produced in which tissue? All right, there we go. Okay, so anterior pituitary gland. So the reason that the ovary may have been a little bit confusing here is because the ovary is the target tissue of luteinizing
Okay.
hormone. So it's made in the anterior pituitary gland, jumps into the bloodstream and travels to the ovary, and that's where it does its job.
I have a quick question.
Yeah, bring it on.
So you know, you're saying that it was prostaglandin that will lyse the CL, right?
Yep.
So you said it was because there's like the body knows there's not pregnancy. Like, how does like it know? Like, is there like hormones that the fetus like kind of secretes that tells the body that, or?
Yeah. So livestock species do it a couple of different ways. Cattle is probably the most straightforward example. So when a conceptus or a fertilized embryo is it's fertilized in the oviduct, right? And then it travels down to the uterine horn, and then it gets into the uterus. And so as that embryo is bouncing around the uterus, it's also producing a hormone called interferon tau. So if interferon tau is present, the uterus is not going to produce prostaglandin F2 alpha. So that's the mechanism in cattle and sheep, and pigs is a little bit different. Mares are really different. Mares are like, horses are weird. They're from dinosaurs, I swear. So mares actually will respond to and produce prostaglandin F2 alpha in response to a lack of activity in the uterus. So the embryo elongates in the uterus of a mare. It's not round. It doesn't grow out like this symmetrically. It elongates into spaghetti looking shit. And then it will bounce around the uterus, and it has to hit like 2 to 3 times a day in order for prostaglandin to not be produced.
Okay, thank you.
Yeah, you bet. Good question.
So when the corpus luteum is intact and it's an ovary, is that when pregnancy can occur and it continues into where you're then developing the fetus, or is when the corpus luteum is intact, that's when you cannot have any sort of pregnancy occurring because it's not allowing the follicle to grow?
Both. So
Boy.
So, so it's when the corpus luteum is dominant on the ovary and it is cranking out a ton of progesterone, it is not allowing the uterus to produce PGF2 alpha if an embryo is present, right? So it's like that game of like, this can't happen unless this happens. And that can't happen unless this happens, and that can't happen unless this happens, right?
Yeah.
It's all one big cycle. So when prostaglandin is being produced in large amounts, because the CL is the dominant structure on the ovary, it's feeding back to the uterus and it's quieting everything down, so that if a conceptus or an embryo is in there, it can actually attach to the uterine wall. And if that attachment doesn't take place by a certain time point, so it's usually day 16 in cattle.
Okay.
So 16 days after ovulation, then interferon tau is not going to be produced, and PGF2 alpha will be produced. It'll travel to the CL on the ovary and kill it. So it can start the cycle over.
You said prostaglandin earlier. Did you mean to say progesterone?
Probably.
The CL doesn't produce prostaglandin, right?
It does not, no.
Okay. So you meant progesterone.
Yeah.
I was like, wait, what? Okay, so it produces progesterone. If that certain time period does happen and nothing is in the uterus to grow, then the PGF2 alpha then is sent to the corpus luteum to destroy it so that it can be remade.
So that the follicle can become the dominant structure on the ovary.
Okay.
And so the follicle, remember, is not only producing progesterone, but it contains that egg, right?
Okay.
Yeah. So if the follicle is allowed to grow, become dominant, put out a ton of estradiol, it eventually is going to ovulate because of high levels of estradiol.
Okay. So corpus luteum, obviously it would never be able to, if it's dominant, and can never lead to any sort of a pregnancy.
No, but it can help sustain pregnancy.
Whoa. So what's its main role if there's no pregnancy?
So if there's no pregnancy, its main role is to quiet the uterus so that a supposed pregnancy can get established.
Got you. And when there is a pregnancy, then it helps still quiet things, right?
Right. Yep.
Interesting. That's really cool.
Yeah. Repro is awesome.
It's very interesting. I'll say that.
It's way better than nutrition. Please tell Dr. Phillips.
Thank you.
You bet. Awesome, guys. Well, we're 4 minutes over and I have a 1 o'clock appointment. I'm so sorry. I hope today was helpful. Just be ready, and I would start early and often with the second half of the material this week, because there is some heavy lifting. We're going to talk about cellular things and this thing has to bind to this thing, and that causes this, and that causes this inside the little baby cell before you can actually get like a hormone produced. So we're taking it to a really deep, deep, smaller than microscopic level. Okay,
Thank you so much
is all
for-
good?
Thank you for spending time doing this.
Absolutely. Thank you for coming to the Zoom session.
Of course.
Thank you.
All right, we'll see you guys.